Okay, third years, just wanted to run through these notes very quickly with you to make sure that you're clear on them before you attempt some of these questions. Now, you've done lots of work on these already. Translations, as I said, we've got two types, either central symmetry or axial symmetry. Nice and straightforward, we'll run through them now. And then we've got a little bit on axes of symmetry, and then this last bit then is on rotation, and I haven't written any notes on that, but I'm just going to draw a very quick diagram on a rotation on the next slide here. So that's all we have to look at today, and then attempt some problems on these. These notes are just showing down from what's in the textbook, so between that and what's in your textbook, you should have no issue being able to attempt these questions that I'm giving you to get done today. So we've got, first part is a translation, when we just move a point or an object in a straight line. You can see in the instance here, I'm talking about the translation A to B, and you can see I've drawn a triangle which is DEF, and its translation, as you can see in this case, I've moved right 3 spaces and down 1 space. So like if you look at the boxes on the page, we've moved to the right 1, 2, 3, and we moved down 1. So we're going right 3, down 1. So that's what's happening with the triangle DEF. The triangle DEF is being translated, and it's becoming D prime, E prime, and F prime. And as I said, it's just like an apostrophe, but we usually use that terminology and we call it prime. And as I said, it's just exactly the same shape, it's just moved position somewhere. So that can happen on an XY plane mostly. Most of the time it's on an XY axis diagram, and it's a graph that way. Through central symmetry, same idea, but we map each point. In this case it's X, Y, Z, that triangle. They're being mapped to the point C, and then they're being mapped again. So you figure out how far you have to move. So let's say this one here is the point X. I have to move across, and I have to move up to the point C, and then I have to do the exact same thing. So you're going to move across and up to X in that case. Okay, and you do the same for Y and the same for Z, but each one is different because each one is a different distance away from the point C. So what you do to point X and what you do to point Y and what you do to point Z are all different because they're in different positions away from the point C in this case. Now that could also be asked to be done through a specific point. So you can see it's through the point C here, but they might ask you to rotate something, they might ask you to translate something through a specific point. So let's say the point is 1, 2, for example. They might give you a triangle, nice simple one, and they ask you to translate that under central symmetry through, it could be the origin, most likely, or most of the time it's through the origin. So you would have to map each of those through the origin, and it would be something like that to there and back again, and you'd end up with a triangle like that. As badly drawn as that is, but you get the idea. It could also be done, imagine, through the point. So imagine the point 1, 2 is going to be like somewhere there, say, for example, on our XY plane. And if I was mapping that, then I have to map these 3 through that, and you can imagine the triangle is going to end up somewhere there, maybe, kind of. Okay, so you go from there to there to there and across through the point, and you make your new triangle in the different position. And as you can see, it's a complete inversion. It becomes upside down and back to front, so a full flip on its axis of symmetry, if you really want to think about that, and then turned upside down also. When we do it under axial symmetry, we do it either through the x-axis or through the y-axis, which is perfect. You can see the triangle that I've given you here. We've got the triangle ABC. When we pass it under axial symmetry through the x-axis, it goes down. You can see from A, we map to the x-axis, and then we do the same distance again. B to the x-axis, and down again, and then C to the x-axis and down again. And you can see the length of the line here above the x-axis and below the x-axis should be the same. You're just going down 5 spaces or 4 spaces or 2 spaces or whatever amount it is depending on the point. The exact same thing for our y-axis. You can see A to the y-axis and across, B to the y-axis and across, and then C to the y-axis and across. And those lines all match up to one another. Our last bit there, as I said, is on axes of symmetry. Little explanation there, you can have a read through, and you know different shapes have different amount of axes of symmetry depending on what they are, and some shapes have none, as you know also. So that's just an extra bit of note, an extra couple of lines of notes there for you to explain that a bit further. The last bit then is a rotation. I just wanted to show you very quickly. If we rotate something, you can imagine you rotate it maybe 90 degrees. We've got a triangle here again. It's got 3 points, and we rotate that point by 90 degrees, that point by 90 degrees, that point by 90 degrees. And we'll end up with the triangle just turned on its side or turned to the right. And you can imagine you can have 90, 180, 270, 360 would end up back where it came from. But you can imagine that that triangle, if it was, that's 90 degrees there. If it was 180, it would be down here. If it was 270, it would be like that. And it's been rotated, rotated, rotated. And as I said, 360, you'd end up back where you came from. Okay, so that's all of the info needed for these. As I said, the notes that I've written there on the page, I'm going to put a picture of that up on Google Classroom for you to use for your own notes if you want to. And then with all that information and this video, we should have no issue being able to attempt the questions that I've given you today. Thank you very much.